Hello everyone, welcome back to the channel AI with Manvinder, my experiments with AI. Recently I came across this very interesting and recent GitHub repository by Andres Karpathy, and honestly it blew my mind. It has received massive 78,000 stars. Now Karpathy is not a new name in the field of large language models. He is a veteran in AI research and has contributed significantly to the field. Now this repository is called AutoResearch, and what makes it special is not just what it does, but what it replaces. Let's take a step back. In traditional machine learning or data science workflows, we usually go through these stages, like writing code manually, training models, evaluating performance, identifying bottlenecks, tweaking hyperparameters, and repeating the entire process. Even today, that is our meet computers or a traditional era, we are doing it slowly in a manual intervention as everything requires a manual interventions. Now we shifted from this traditional to vibe coding, that is our current state, in which we are using LLMs to generate code faster, and that is reviewed, but still the bottleneck is the human manual reviews. We can review only one feature at a time. Like still humans are still needed for which model architecture to use, which hyper parameters to tune, whether the performance actually improved or not. But right now, the third era, the frontier, with the introduction of auto research, is AI agents run experiment. They iterate continuously, they operate in a closed loop, and most importantly, without human interventions. Now, if I do the architecture breakdown, let's understand how auto research works and what's under the hood. It mainly revolves around three key files. First one is basically program.md. This is basically human defined goal, and this is most important file. Here you define the objective, like improve accuracy, reduce RMSE, some constraint that like do not remove the certain features, evaluation criteria. So basically think this as the rule book for the AI agent. Second file is train.py. This is basically agent controlled experimentation. And this file is continuously modified by the AI agent, used to run experiments, updated based on performance. Like if an experiment improves the results, it will be kept. If not, then it will be discarded, and it will go back to the previous changes by discarding the new changes one. The third one is basically the prepare.py. It is immutable evaluation layer. So it basically contains the test data, scoring metrics, and most important, the agent cannot modify this file. It acts as a fair judge of performance. Main idea for the third file is if agent started peeking into this prepare.py, agent can identify 1,000 ways to cheat the model. So to avoid that, agents are not and allowed to make changes in the prepare.py file. Now, how it works? The core concept basically lies in the ratchet loop. What is ratchet? So, most basically, if you remember, this is a mechanism that is available in our bicycles. To be honest, when we push forward, we have to put force. If you are reversing back, there is no energy involved. So basically, in auto research, the same way, if we make any changes, we do the experiment like the force that we are put applying to the ratchet. If the experiment doesn't work, then if we go back, there should not be energy involved. An agent runs the hypothesis, it runs the experiment, and it evaluates the performance. If it is better, then it accepts the changes. If it is worse, then revert. There are some golden rules to it to make it work more effectively. So these are basically you should have a clear metrics defined on which the agent will do the optimization. Be it accuracy, F1 score, RMSE, it must be well defined. No vague goal or subjective goal should be there. Second is the one file to edit. Only train.py file will be editable by the agent. Third one is the experimentation should be time boxed loop. Each experiment runs with a fixed time, maybe 5 minutes, 10 minutes, 15 minutes. That can be a user defined. But if it takes too long, then agent will discard the current experiment, current changes, move back to the previous one, and define comes with a different hypothesis and do start the experimentation again. And the beauty for this overall auto research is it's versatility. You can it apply it to any machine learning problem, software engineering optimization, finance and operations, marketing and growth. As long as you can define a metric, auto research can optimize it. So essentially, what we are seeing is a shift from human doing experiment to AI agents continuously improving system on their own. And this could fundamentally change how we build and optimize models in the future. Now, we will move to how actually we can use this auto research to improve our current systems or machine learning problem that I have. I have taken a house pricing data set available on Kaggle. It includes features like kitchen area, uh, garage cars, garage area, garage quality, condition, porch, and whether fence is available or not, these kind of features. And output variable is the selling price for the house. So we have to predict it. Currently, what I have developed is a basic multi-linear regression model, MLR model, that is giving me the accuracy level of like R square level of 0.86 on training and 0.85 on test. It will act as my base model, and I will give this to auto research to further improve my R square as well as mean absolute error. For that, I'm using GitHub Copilot, and I'm defining a prompt that making it as autonomous ML agent working in auto research framework, and I've attached the GitHub repo. I've defined my goal, my constraints, the strategy, logging, and output. And I was asking you to start experimentation. So this is just wow. So right now my all experimentations are complete. Let me just walk you through. So it started with some baseline results as first experiment, and in the second experiment it changed the model from random forest to XGBoost, and then it used light GBM. The light GBM results were not that good, so it again got back to XGBoost. Then it tried using gradient boosting. Then it added some extra trees to it with some hyperparameter tuning. Then it tried ensemble learning, and then it again tried stacking regressor. Then it identified that stacking is not helping, so let me do some log transformation of my output variable. Then it's after log transformation it saw that R square is significantly improved from a validation set. Then it did some hyperparameter tuning of voting ensemble with log transformation, which was lower. Then it did some XGBoostic tuning. Then it tried a light GBM with log transformation. So it created the final model that is XGBoost with log transformation that performed best. And it has also given me my experimentation results. So with each result, which R square it was able to get, it started with the baseline and then which experiment gave the best one, and MAEs was which was lowest in which experimental 12, and RMSE was also lowest out of these on 12. So this is one. If I see another chart, so this was this. So this is interesting. So it is showing the over experimentation. What is my validation and test set MAE, RMSE, and R square. So it has reduced my experimentation time from say 3 to 4 days, because if I do it by myself, it would take that much. But it has now reduced down to say 15 to 20 minutes. So this is the power. This is the future that we are going to. So today we have just only covered the basic experiment, that is using the basic machine learning problem and improving it. In the future, we will experiment more using auto research on some sophisticated problems like improving the overall LLM, changing the architecture of commerce based forecasting models. And don't forget to like, share, and subscribe. This is Manvinder Chahar, and you are at the channel AI with Manvinder. Thank you so much.